Welcome to Peaks to Power, a podcast brought to you by the U.S. Department of Energy's National Laboratory of the Rockies. It's Wednesday, June 3rd. I'm Karen Jerriman.
And I'm Taylor Mankel. How you doing today, Karen?
Hey, Taylor. I'm doing all right. Thank you, and hope the same for yourself. It's June, which is crazy. I can't believe we're already here. And I'm excited for this episode. We're talking about space travel, a first-of-its-kind testbed opening at the laboratory, and a semiconductor catalyst that captures energy from the sun.
Real exciting stuff. We got a full episode, so let's get into it. In early April, the Artemis II mission sent the first crewed flight beyond low Earth orbit since the Apollo 17 mission in 1972. The 4 NASA astronauts on the mission relied on lithium-ion batteries in communications, navigation, propulsion, and thermal systems.
Making sure these batteries were up for the mission is a challenge that scientists at the National Laboratory of the Rockies have spent more than a decade to address in close collaboration with NASA.
And as it turns out, the best way to make sure batteries are safe is learning how to make them fail.
Ooh, it seems like fun and may seem a little backwards, but if we know all the ways a battery can fail, we can plan for those failures. In the worst-case scenario, a flaw in a battery introduced by a speck of dust could bring down an entire space capsule and its crew. Something so tiny could cause catastrophe, which is why NASA has some of the most rigorous battery safety standards in the world.
Yeah, it makes total sense, and that really reinforces why testing to failure is so crucial. And NLR scientists break batteries so well that NASA actually awarded them and industry partner Cooler Technology Group, Cooler spelled K-U-L-R, the 2025 Invention of the Year for their internal short-circuit device.
Yes, this internal short-circuit device, also known as ISCD, is implanted into lithium-ion cells, triggering battery failure that improves battery testing for space-bound systems.
According to the former battery technical discipline lead at NASA's Johnson Space Center, the ISCD is the preferred method of conducting battery tests for all manned missions.
Researchers have several methods to analyze battery failure, like using tests to measure rising temperature changes of the device caused by chemical reactions, or examining the composition of battery materials with high-speed X-ray diagnostics. Historically, these tests were limited to external triggers like overheating, nail penetration, and crushing.
While these tests play an important part of battery safety research, these approaches can't quite replicate the unique reactions that occur when microscopic manufacturing defects cause an internal short circuit.
And that's where the ISCD comes in. Remember, that stands for Internal Short Circuit Device. The device allows researchers to examine how cells react to internal triggers and design specific thermal management strategies to mitigate battery system failures caused by such defects.
The lab's ISCD helps ensure battery systems can handle extreme operating environments. Scientists can run tests repeatedly until their battery system designs can withstand and diffuse isolated incidents caused by unseen manufacturing defects, even in the most demanding applications, like a round trip to the moon.
No wonder this technology was NASA's Invention of the Year. It's helping keep the spacecraft circling the moon and allowing us to explore space safely.
It is also keeping us safe here on Earth, as batteries grow more powerful and more ubiquitous. In the cars we drive, the planes we board, and the phones in our pockets, the ability to understand exactly how they fail has never been more critical to ensure safety.
The ISCD is now used by more than 80 companies, including SpaceX, Tesla, Toyota, and Volkswagen, to test the batteries powering commercial aircraft, satellites, and vehicles.
Super impressive. Congratulations to the NLR team, including Senior Energy Storage Engineer Matthew Kaiser and Emeritus Energy Storage Engineer Ahmad Pessaran. We talked a bit about Artemis and Apollo missions in our last story, so let's keep our Greek terms moving here into the next story about the Agora testbed.
Yes, let's. The Agora Large Load Testbed is a first-of-its-kind national capability designed to help data centers become active participants in grid reliability. Funded by the Department of Energy's Office of Electricity and industry partners, Agora was designed in close collaboration with industry and utilities to address real-world challenges.
It is the only dedicated large-load grid integration testbed across the U.S. National Laboratory Complex and replicates the technical complexity of a large-scale data center interconnection.
Agora, to your etymologic point, Taylor, was an ancient Greek public gathering place for discussion and exchange. Similarly, the Agora testbed convenes utilities, data center developers, technology providers, and researchers across the country.
By bringing all these stakeholders together, we can learn ways to address the electricity demands of data centers while protecting or even benefiting the grid.
Exactly. So historically, most data centers have operated primarily as large electricity consumers, with limited opportunities or incentives to actively support the grid. Utilities also have limited insight into whether these facilities can temporarily reduce or shift operations to help maintain reliability. By adopting flexible designs and cost-saving operational practices, large loads like data centers could lower electricity rates for everyone.
Martha Simcoe Davies, NLR Laboratory Program Manager for the Office of Electricity, said using Agora and the integrated detail it provides is essential to help data centers establish themselves as, quote, good grid citizens, unquote, energy users that share the responsibility for keeping the grid reliable.
I love that. We should all aim to be good grid citizens. All right, Taylor, do we have any Greek words in our last story?
I suppose you could get there, only the ways in which most scientific terms have some underlying Grecian roots.
All right, fair enough. I'm here for it. And this one has plenty of scientific terms. We're talking about our basic energy sciences research at the laboratory, specifically the fields of artificial photosynthesis and photocatalysis.
Plants and algae make their fuel from sunlight, and a team of NLR scientists is working on doing the same thing with silicon semiconductors coupled to molecular catalysts.
Yeah, this is really interesting stuff. The NLR scientist Discovery can capture higher energy sunlight. NLR research scientist Nathan Neal says this work could push the limits of how much energy we can yield from the sun.
Exactly. The sun has so much more energy than we currently use, and if we could capture it, that'd be huge. Using this hybrid system, a silicon semiconductor with a molecular catalyst, we can keep photo-generated electrons energetic long enough to use in chemical reactions.
In the study, the electrons stayed quote-unquote hot for at least 5 nanoseconds, which isn't a long time, but it is 25,000 times longer than the typical amount of time it takes hot electrons to cool down in silicon.
By using these findings to keep electrons hot for longer, engineers could more efficiently split water to create hydrogen or carbon dioxide to create hydrocarbon fuels and harvest more energy.
This work from NLR scientists builds on widespread research to demonstrate that it is feasible to get even more from the sun. Okay, this was a really cool episode. Anytime we can talk about our work with NASA, I am here for it.
No kidding. Love those partnerships. Exciting times all around for the laboratory.
Yes. Speaking of exciting, next week we are sharing a new Lab Notes episode in this feed. The episode dives deep into our work in Alaska and heat pump technology.
It's a great episode. We encourage you all to take a listen. And listeners, thank you so much for coming along with us today. And if you have a minute, go over and give us a 5-star review on your favorite podcast app.
This episode was adapted from National Laboratory of the Rockies news articles from May 2026, written by Rebecca Martineau, Madeline Giocaris, and Connor O'Neill. Our theme music is written and performed by Ted Vaca, and episode music by Chuck Kernick, Jim Riley, and Mark Sanseverino of Drift BC. This podcast is produced by the National Laboratory of the Rockies Communications Office.